So this is our question number 5. Fx equals to mod x plus mod x minus 1. See in the question, which of the following is correct? So we need to discuss its continuity and differentiability at point x equals to 0 and x equals to 1. As you can see in the 4 choices, condition related to continuity and differentiability is given. Okay. So whenever we have two modulus function attached with positive sign or negative sign, then we need to explain it first. Okay. So how to explain it? So in first modulus, inside we have x. So put that equals to 0. We will get certain values of x. Then in this modulus we have x minus 1 inside. Put that equals to 0. Again you will get some values of x. Now we need to show this value 0 and 1 on number line. Okay, like this. So this number divides this number line in 3 parts. One is less than 0, another one is from 0 to 1, and the next one is from 1 onwards. And the next one is from what? 1 onwards. These are the 3 parts here. Okay. So now we can write this as, for the first part, x is less than 0. That means this side we are considering less than 0 part. And the second part we are considering when x lying between these regions 0 to 1. Okay, greater or equal than 0, less than 1. And in the third part we are considering x is 1 or greater than 1. Okay. So what is the procedure? We need to put the quantities inside mod equals to 0, collective values of x, so on number line. Then observe that in how many parts these points divide number line. In this case we have 2 points, so it divides in 3 parts. We need to consider that 3 part. In this case x is less than 0 is your first part. Second part is 0 or more than 0 up to 1, that is the second part. And in the third part it is 1 when x is 1 or greater than 1, that is third interval. Now we have to write these modulus here according to this interval. We can see coefficient of x is positive in first modulus, and second modulus also coefficient of x is positive. What we mean by this? When coefficient of x is positive, then at the point where this quantity is 0, left to this the output of mod is negative, and right to this the output of mod is positive. So where we are, this is 0.10, we want to write output for x less than 0. Suppose this is 1 point for x less than 0. So with reference to this point is left to 0. So the first case this modulus is negative. Similarly this point is left to 1 as well, 1 के भी left में है, so this is also negative. Getting it? In the same way we have to write output for the second case, 0 to 1. Consider any input or any point for reference in this interval. Suppose we have 1 point here from 0 to 1. So this point is right to 0. ये point कहाँ है? 0 के right में है. So if this point is right to 0, then this modulus is positive in this interval. But this point is left to 1. ये point 1 के left में है. So this modulus is what? Negative. ठीक है? Now for x greater or equal than 1. Suppose we have one reference point here. So this point is right to 0. 0 के right में है. So mod x is x. Output is positive. And this point is right to 1 as well. 1 के भी right में है. So this is also positive. The second one. ठीक है? अगर आपको कहीं कंफ्यूजन लगे तो फिर आप बैक जा करके वीडियो को वापस देखें. Okay. So we can simplify it little bit. When we will simplify this, what we will get? Minus x minus x minus minus plus 1, that is minus 2x plus 1. for x less than 0, x minus x plus 1, that is 1 for x greater or equal than 0 less than 1, and in the third case x plus x, 2x minus 1 for x greater than or equals to 1. These are the three outcomes here. Now escape this function. So how to escape? For x less than 0, put x equals to 0 here, minus 2 into 0 plus 1. Treat it as a boundary condition 0. Put x equals to 0, minus 2 into 0 plus 1, that is 0 plus 1, 1. Okay, so for x less than 0, output is 1. What is this? fx na? Fx, that is y equals to 1 at x equals to 0. So this is your point 1 less than 0, open interval. Take one more point other than 0. Suppose we are putting x equals to any less than 0 point. Okay, minus 1. So minus 2 into minus 1 plus 1. Minus 2 into minus 1 plus 1. That is what? 2 plus 1, 3. So at x equals to minus 1, output is 3, 2. Suppose this point is 3. Okay, we will get this point. So just join this point like this. This is the curve minus 2x plus 1. Now the next output is 1. Y equals to 1 for closed 0 to 1. So for closed 0 to 1, that means this open interval becomes closed interval now due to this greater or equal sign. And y is 1 up to 1. So we should go like this. At 1 we have open interval. Now the last case, y equals to 2x minus 1. Put x equals to 1. First of all, this boundary case. 2 into 1 minus 1. 2 minus 1, that is 1. So at this point only we have. Consider any other point. Suppose x equals to 2. So 2 into 2, 4 minus 1, 3. At x equals to 2, what we are getting? 2 into 2 minus 1. 4 minus 1, 3. So this point is 3 here. Join this. So this is the graph of the given function mod of x plus mod x minus 1. Now we can apply that if there is no breaking point, then there is no discontinuity. Number of breaking point equals to number of discontinuous point. Right? Graphical checking for continuity. So we have no breaking point here. So function is continuous everywhere. Now how to check differentiability using this graph? If we have sharp edge, then number of sharp edge is equals to number of non-differentiable point. So we have one sharp edge at this point. See, this is treated as what? Sharp edge. Sharp edge. Okay. So we have one sharp edge at x equals to 0. This is your 0 point. And another sharp edge is at x equals to 1. So at these two sharp edges, function is not differentiable, but it is continuous everywhere. So function is continuous everywhere, but is not differentiable at x equals to 0 and x equals to 1. Okay, then check your choices. Fx is continuous but not differentiable at x equals to 0 and x equals to 1. Choice C is your correct answer for this question. So C is correct answer. Okay, thank you.